Hello. So this is a series of videos I would like to make to introduce you to the concept of potential energy. There's a lot of misconception around this potential energy, and I would like to start with the common understanding. Okay, so imagine you have the earth here and a ball is freely falling. So we know that there is a gravitation force of Fg, and let's mark the points A and an intermediate point B and finally C. Let the distances be x and h minus x, and of course from A to C that'll be h. All right. Let the body start from rest. So your UA is 0, so your KA is 0, and you can call it U or V. Let's call it V. Your VB, we don't know what that is. We can find out from kinematics equation. VB squared equal to VA squared plus 2G into X. This is 0, so that is 2gx. The kinetic energy at this point is half m VB squared. That's half m into 2gx or mgx. Similarly, your kinetic energy at this point is going to be mgh. So we have the scenario where the gravity is doing work in moving the object from A to C, and that is equal to mg, which is a force of the gravity, into h, and that's mgh. And that is this work done on ball increases kinetic energy, right, by mgh. So this work done by gravity, we virtually imagine that it's there in a bank of energy, and we call that bank of energy as potential energy, right? Potential energy. So this is nothing but, we call it potential energy, and this could be more appropriately called potential for energy. And this is nothing but a bank of work, and a bank of work that the earth is going to do on the gravity of earth is going to do on the ball, and that's nothing but that's equal to mgh, right? So this is a potential, if you may want to call it. This is nothing but, this is a potential work that gravity will do on the ball. So we introduce this idea called potential for energy, and at this point, at the point A, this is a situation. You have the potential energy, which is UA, is potential for energy. UA is mgh, and there is no kinetic energy. So there is no kinetic energy. So I'll say K is 0, and your U is mgh. Okay, so remember, this is potential work that gravity will do on the ball. So this is not real, no? All right, so now as it comes down to the point B, part of that potential for work is transferred to the ball, and the kinetic energy at at this point is mg into x. That leaves your potential for energy as mg into h minus x, because initially you started off with mgh, so you've taken away mgx, so the rest you have is mgh minus x. So that's your u, and this is equal to your k, right? And as you come down one more level, which is to c, you have exhausted all your currency, which is your potential for energy, and then all that has been converted to kinetic energy, right? So this is a virtual concept that we know, mgh, which is equal to k, and this is u is all the energy has been exhausted. So this potential for energy is a virtual concept. It correlates to the net work that gravity will do on this ball, which is mgh, which is this quantity, right? This quantity. So this concept is very handy concept because it helps us to apply law of conservation of energy, which is, we can say Ka plus Ua equal to Kb plus Ub, or in other words, I can say that Kb minus Ka plus Ub minus Ua equal to 0, or delta K plus delta U equal to 0, right? Now remember, your delta U in this particular case is Uc minus Ua, that is 0 minus mgh minus mgh. In other words, your delta U can be written as delta U is minus of the work done by gravity in moving from A to C, which is, or rather you can also say delta U is minus work done by gravity from initial to the final position.